Hi Year 10 and welcome to the first class for Chapter 5, and we're going to be dealing with expressions, equations and linear, which is straight line, relationships. And the first lesson is all about just doing a bit of revision on algebra, making sure we don't forget things. So if we have a look at our first piece of information here, we have an equation, and it's called an algebraic equation because it's algebraic because there are letters involved, and it's an equation because we have an equal sign involved. Now on the left side of the equal sign, we have an expression. So we've talked about an equation. Equation has an equal sign. An expression is what's on either side of the equal sign. And it's terms that are connected with pluses and minuses. You don't have to have two pluses, or you don't have to have a plus, you don't have to have a minus, you can have both minuses, both pluses, you can just have two terms, it doesn't matter. But between the pluses and the minuses we have terms. Now where we see that minus is actually linked to the 7y, so it's negative 7y as a term. That plus is linked to the 2x, so it's plus 2x as a term. If you can't see anything in front of the first term, it's positive, so positive 3xy as a term. Positive 12x is a term, negative 5y is a term, and positive 10 is a term. Now coefficients are the numbers in front of terms, so the coefficient of x is 2, the coefficient of xy is 3, the coefficient of y is negative 7, the coefficient of x is 12 over on the right side, the coefficient of y is negative 5, and this is called the constant coefficient, or the constant term, and it's just 10 because there's no x's or no letters with it. And remember, a fancy word for a letter is just called a pronumeral in maths. Now remember, when you are adding and subtracting and you're doing algebra, you can only add and subtract like terms, so the letters must be the same. However, when you're multiplying and dividing, well, you multiply numbers with numbers and you divide and you multiply letters with letters, and when you're dividing there's a trick, and we go back to primary school for that, and it involves turning the division sign into a multiplication sign and flipping a fraction, and we'll do an example with that in a moment to see if that makes sense. Remember, when we're expanding, it means we're multiplying the brackets out. 2 times a, 2a, 2 lots of 3, 6. Factorizing means take something and putting it into brackets, so there's the same question written in reverse. When you get rid of the brackets, you're expanding. When you take the expanded form and you put it back into brackets, it's called factorizing. Let's have a look at our first example here. So, first one says simplify 7y plus 8y. Well, they both have y's, so they're like terms. 7 plus 8 is 15, so the answer is 15y. Let's go to part B. With part B, I can see that there is a term that has a 3mn, another term that has a 8nm. It doesn't matter about the order of the letters as long as the letters are the same. So 3 plus 8 is 11, so I have 11 lots of. Now should I write mn or nm? Normally we choose the alphabetical order. Now the plus 2n is different. It's a different term to the minus 5m. So when we're writing our answer, the 2n can't add to anything and the 5m can't subtract to anything. There is our final solution. Let's go to part C. For part C, we've got a y squared term, and there's no other y squared term, so in the answer there is just a 7y squared. When I look at the plus 3y, there's a plus 6y, so there's two y terms, plus 3 and plus 6 make plus 9y, and for the last one, minus 3x squared, because it can't add with y's. There is your answer. And finally, we have a squared b term. There's no other term that has an a that's squared and a b. Oh, yes, there is. There's one on the end. It's just written in reverse order. There's an a that's squared, and there's a b term. So what I actually have here is -2 of them plus 1 of them, which leaves me with -1 a squared b. Now because there's a -1, I'm going to put a minus there. I could write -1, but I'm just going to put a minus sign there. Now when I look at the second term here, it's got an a and a b squared. There are no other a and b squareds terms. Minus 9a squared, because there's no other terms that just have an a squared. And you'll see that I've made a little mistake there. That's better, fixing up that second term. So the second term is minus 44ab squared. So there's example 1 finished. Let's try our second example. Our second example involves multiplying and dividing. So when we look at part A, we're multiplying. So look at the two number parts. You have a 2 and a 5. 2 times 5 is 10, and we have the letters A and M left over, so 10am is the answer to that one. When we go to part B, we have a 3 and a 4 and a 1. 3 times 4 is 12. 12 times 1 is still 12. The letters left over are M, N, and E. And I could write it as 12E, M, N if I wanted to put the letters in alphabetical order, but the top part is still correct. Let's go to part C. Part C is a fraction, and we're dividing things. So let's have a look at the letters. You can see that the B's will cancel. You can also see that 2 goes into 8 4 times, and 2 goes into 14 7 times. So we're cancelling first. Once we've cancelled everything, then we're going to write our answer down. On the top, I'm left with a 4 and an A. On the bottom, I'm left with a 7 and a C. So there's my final answer. Let's go through the cancelling process for part D. Let's have a look at the numbers first. 16. 16 goes into itself once, and 16 goes into 32 twice. Let's look at the letter A. I've got 3 of them on the bottom, and I've got 7 of them on the top. So if I cancel 3 of them off the bottom, with 3 of them from the top, I'll be left with 4 of them still on the top. Let's look at the letter B. The letter B, there's just one letter B and one letter B. They'll cancel each other out. And finally, let's look at the letter C. So for the letter C, there's one letter C on the bottom, which will cancel one of the C's on the top, which means I'm left with 3 of them. So what's my final answer? On the top of my fraction, I've got a 2, an A to the power of 4, the B is gone, and I've got a C cubed. And on the bottom, everything's cancelled. I'm just left with a 1, which is just better written as 2, A to the power of 4, C to the power of 3. Now let's have a look at part E. Part E is another question where we are dividing. But there's a little trick that can sometimes be used to make these questions a little bit easier, and that is rewrite the question as a fraction with the first part on the top and the second part on the bottom. Then when you look at it, you can cancel. Let's look at the numbers. 7 goes into itself once, 7 goes into 14 twice. Let's look at the letters. M cancels with itself. That one M cancels with one of the M's on the bottom to leave me with just one. And the N's, well, both the top and the bottom have an N, they'll cancel each other out. So what am I actually left with after all that cancelling? On the top, I'm left with 1 because the M and the N are gone. On the bottom, I'm left with 2, M to the power of 1, which is probably better written as just 1 on 2M. Let's try that same process with part F, where we write it as a fraction. So it becomes minus 7PQR over 21Q squared. Let's go through that cancellation process, looking at the numbers. 7 goes into itself once, and there's a minus sign there. 7 goes into 21 3 times. The letter P, there are no P's on the bottom to cancel with. The letter Q, the letter Q. There's one Q on the top, it will cancel one of the Q's on the bottom. The letter R, there are no letter R's on the bottom for it to cancel with, so our final answer on the top is minus 1 P R. Notice I didn't put the 1 there because I knew I had a P and an R. You can if you want. All over 3Q, because there's still that Q left over there. So there's some examples on multiplying and dividing. Let's look at the third example where we've got to expand first and then simplify. So let's go through the expanding process. First of all, 2 times A is 2A. Then we do 2 times 7, which is 2 lots of 7 is 14. Then we do positive 3 times A, which is positive 3A. Positive 3 times positive 2, which is positive 6. Now we add the like terms together. I've got some A's there. 2A plus 3A is 5A. I've got the number 14 and the number 6. Positive 14 and positive 6 add to give positive 20. So the first line of working here is the expanding, and the second line of working is the simplifying. So we expanded first and simplified second. Let's go through that same process now for part B. 3G times G is 3G squared. 3G times 5 is plus 15G. Negative 5 times 2G is negative 10G. And a negative 5 times a negative 3, two negatives give a positive, and 5 times 3 is 15. So that is the expanding stage. Now, when you look at the 3G squared, there are no other G squared terms. So in my solution, I'll have a 3G squared. But when I look at the G terms, I have plus 15 minus 10, which gives me 5. So I get plus 5G, and the plus 15 can't be added to any other numbers because there are no other numbers. So the first line of working is my expanding. The second line is my simplifying. Let's go to our next example. Example 5 is all about factorising. So let's look at part A obviously first, and what we're dealing with here is two terms. We're looking for what is common in each term. What number goes into 9 that also goes into 12? Now you have to be good at being able to do your dividing here, your division or your multiplication. 3 goes into 9 and 3 goes into 12. So I put down 3 and then a bracket. Now when I look at this, how many times did that 3 go into 9? Well, 3 times 3 is 9, so 3 went into 9 3 times. There's still an M there. How many times does this 3 go into 12? Well, 3 goes into 12 4 times because 3 4s are 12. And there is a minus sign in the question, so it's minus 4. You can do a quick check. 3 times 3 is 9M. 3 times 3M, 9M. And 3 times negative 4, negative 12. Let's go to part B. We're looking for the number parts only. What number goes into 25 that also goes into 15? Well, 5 does, doesn't it? So we write down our 5. Now let's look at the letter parts. You've got an A term and an A term, but that's A to the power of 8. That's A to the power of 6. That means A happens at least 6 times within each term. So I end up taking out A to the power of 6 and put my brackets. Now, if I look at the first term, 5 went into 25 5 times. And A to the power of 6, well, I've used up 6 A's, and there's actually 8 of them, so there's still 2 I haven't used. So I've got A squared. Put down a plus because there is a plus there. 5 goes into 15 3 times. And A to the power of 6 has been used, and there's A to the power of 6 there. I've used up all the A's, so that's my final answer. Let's go to part C. Now with part C, because the first term is negative, I want to take out minus. Now 4 and 28, 4 goes into 4, 4 goes into 28, so I'm going to take out minus 4, which will leave me with D, because if I've taken out minus 4, I've only got D left. 4 goes into 28 7 times, but I'm going to put minus 7 here, and let's see if we can check why. What's negative 4 times D? Negative 4D. What's a negative 4 times a negative 7? Two negatives make a positive, and 4 times 7 gives positive 28, so the bit in blue is the answer I'm looking for. Going on to part D. E is common to each of the terms, and when I look at the first term, I've used one of the E's up, so I'm still left with an E, minus. When I go to the second term, really there's like a 1 there, and if I've used up the E, there's still a 1 I've got left there. So there's my answer, E, and then brackets, E take 1. Well, it's now time for you to try questions. Enjoy the experience, because algebra is lots of fun after all. Bye for now.